So this is a lab 7 stepper motors. So in the pre-lab question, it's asking us to find how many motor steps there are for one revolution. So for the motor that I have, looking at the data sheet, it has 4 phases and 8 north poles. So we do 2 times 4 times 8, which is 64. And for my specific motor, the reduction rate is 25. So we do 64 times 25, which is equal to 1600. So the motor that came with my lab kit is the middle one, the -25 one. And then you can see that the gear ratio is 1/25. So moving on, this is my circuit. So I have the power and ground going to my power and ground rails on the breadboard. And I have the motor H bridge right there. And pins 9 through 12 going into the H bridge. And I have all the 4 grounds in the middle right there, those 4 grounds going there. Then I have my battery pack, the positive going into the motor driver right there, and my negative going into ground right there. And this is the motor, and these 4 wires are going into the motor driver. So this is my Arduino code, and I started defining the variables at the top, and I made my pins outputs, and then I have a for loop to make it move in the forward way. And you see that I is less than 200. It should be I is less than 1600, but I don't know why my motor's being weird, and it makes 4 full revolutions when it's 1600, but it makes 1 revolution when it's 200. It doesn't make sense. And then I have another for loop to move in the reverse way. So you see here it's moving in the forward way right now, and then it'll make 1 revolution, then it'll stop, and then it will go 1 revolution in the reverse direction. It will stop. It'll keep doing that. So to control the speed, I have a variable for speed, and I have it at 10 right now. So that variable basically is controlling the delay between the steps. So I have it at 10 right now, and you can see that this is how fast it's moving. And now this is the second speed, which is much faster. So I change the speed to 5 and changes the delay between the steps to 5. So you can see now it's moving twice as fast. So this is question 2. I'm going to show you the 360, 180, 90, and 45 increments in order. So first, this is the 360. It'll move forward and reverse. That's 1 revolution, then I'll move back to the other way. The step size for that 360 degrees was 206, and I found that by a trial and error. Moving on to the 180 degrees, my step size for that is 103. And that's what it looks like. So that's you see you can move forward and reverse. This is the 90 degrees increment, and then for that step size is 52. And you can see it moves 9 degrees, forward and reverse. So lastly, with a 45-degree angle, you just do half of 52, because 52 is 9 degrees. So now step size is 26. And you can see it moves 45 degrees forward and reverse.